about to start. We'll talk about code or whatever we'll talk about today. It's about to start, so please hang tight while I check that everything is okay. Sound check, camera check, lights check. How's my hair? Oh, wait, I don't have any hair. Maybe put some pants on and I am good to go. So get ready wherever you are, 'cause this stream is about to start. Get ready wherever you are, 'cause this stream is about to start. Hello and welcome to another meeting of the C++ Digital Signal Processing and JUCE study group, where we talk about everything but C++ Digital Signal Processing and JUCE. And Today we have a special guest, Aline. We went to college together.
Hey, cool. Welcome. Hey, Aline. Welcome.
Hello.
Yeah.
Thank you.
We are reliving the old times when we would be like writing code together to try and get things to work just barely enough to get a good enough grade. Good old times hacking.
So this was in South America?
You're saying that it was not a good time to write code together?
It's almost never happened. I never was really good on coding, so yeah, I'm just visiting and looking people and admiring this process.
Okay, are you a coder now, or?
We used to make a college together.
Yeah? Are you working as a coder now? Programmer?
No, I'm product owner.
Pardon?
Product owner.
Oh, you lost me. What's that? What is that?
How can I explain? Is the person that's responsible for the management of issues and user stories during the Scrum process with the team.
Okay.
Like a functional analyst, but with the more leadership roles.
Okay. Cool.
Yeah. So you're working with the developers and figuring out what they need to do to satisfy the business demands.
That's it. I actually make the bridge between the stakeholders and the dev team.
Okay.
Architectures and KAs, UI UXs, and all the team members.
Sounds fun.
Is
it?
Cool.
Nice. Cool. Well, again, welcome to the chat.
Thank you.
And as always, we have Bo and Fotis and Siwitz. Hello, everyone.
Hey, Seaweeds. Oh, there you go.
Hello. It's awesome to have you here. So,
who wants to start?
I, for once, I have things to share. I am excited about that. Can I go first?
Sweet. Yes, please. Absolutely.
So, for once I have something to share, and it's not C++. But hey, who is counting? Let's talk about something else. It will be related to digital signal processing, sort of. You'll see. So last week, or I guess last meeting, which was 3 weeks ago, I pitched this idea of doing an electronic wind instrument, the EWI. And it is something that looks kind of like a clarinet, but it doesn't produce any sound. It's just controlling a synthesizer or a computer, sending MIDI signals. And what's fun about this project is that it is relatively straightforward, even for someone who is not super well versed into programming. So I think it's the perfect little project for a study group. And I was interested in getting to know the Raspberry Pi Pico, this little guy. I have worked with microcontrollers before, but I have always used Arduino microcontrollers, which you program using C++. Gasp! We don't want any of that. So for the Raspberry Pi Pico, yes, you can write C/C++. But what sets this apart is that you can write Python for this. And it's still not one of my favorite languages. I don't know Python all that well. I probably know Python less than I know C++, but it is a friendlier language for teaching how to program. And what I want to share is like the absolute basics to get started with this board, because it's super fun and affordable too. The board itself costs €5. And it is very capable. I was surprised by how much you can get out of €5. And here's how this works. First of all, we are going to connect it to the computer while holding this little button. What this does is it sets the board in a special bootloader mode so that we'll be able to load any kind of firmware that we want. And there will be different firmwares with different purposes. So yeah, I just plugged it in. I think that the computer recognized it, but it doesn't give me any visual indication. And I will be smart and share my screen first. Yay, I remembered. So then there is this program called Funny, and it is just an editor for Python. But what's cool about this is that it's aware of the boards and it's aware of how to install stuff on the boards. So if you come here to configure interpreter, then there are two different flavors of Python that you can write for the Raspberry Pi Pico. And the same applies to many other boards, incidentally, so it's not specific to this board. And the two types are MicroPython and CircuitPython. MicroPython is like the lower level Python, and it has all the functionality you need to do LEDs and buttons and everything, but it's fairly basic. And then there's CircuitPython that builds on top of MicroPython with even more features. For instance, USB MIDI or MIDI over USB, which is exactly what we want for the IWI project, because we will connect the IWI to the computer with a cable and send MIDI signals. So I decided to go with CircuitPython. And then you select where your board is connected, which I think is this. WLAN doesn't seem right. Is this connected? Jeez. Ah, right. Okay. So I hope that this is gonna work out. Yeah, it's showing up. Great. So you come here to install CircuitPython into the Raspberry Pi Pico. You select if you had multiple boards. In this case, I only have one here. Then the variant. There are two Raspberry Pi Picos. One is W for wireless. That's not the one I have. And I want the latest version, so I'm going to select this one. And then what's happening now is that it's copying CircuitPython into the Raspberry Pi. This is a setup that you only need to do once. Or if you want to play around with the different flavors, you have to flash CircuitPython, then flash MicroPython. You can flash something even more basic for you to write C++ with. And there is even, and that is an exciting prospect for me, there is even a firmware that allows you to write JavaScript for a microcontroller. And that seems very fun, but it's less support and doesn't have USB MIDI, so the tutorials aren't there. I decided to just go with CircuitPython. So now it's done, and it is already running some boilerplate code that came with the firmware, which blinks the LED, the hello world of hardware. Okay, now that CircuitPython is there and that, I'm gonna try to detect the port automatically. Is that gonna work? Yes, it worked. And it connected to the device. So now it's telling me that this shell, as I write code over here, is going to send the code to the Raspberry Pi and get the results back. So when I do something as simple as this, this 3+4 is being sent over the wire via the serial connection to the Raspberry Pi. The Raspberry Pi is computing 3+4, sending the results back to the computer via the wire, via the serial connection. And that's what is displayed here. So with that, you can start writing code to, for instance, blink the LED. And the code that you have to write to blink the LED is fairly straightforward. So I'm going to copy it from the web. I am going to skip the rest of the tutorial and jump to the conclusion, which is here. And depending on the board, you have to change this pin here. And I think that there is this on the Raspberry Pi. But because I am not sure, what I can do is run this in the shell. So over here is the program. In fact, I shouldn't be pasting things here. I should be pasting things here. So here on the left, you see it's like a file browser. So this is my computer, and this is a file browser in the Raspberry Pi. So as you plug the Raspberry Pi, it turns into a removable device, like a flash drive, with a small file system. And whatever you put in this, oh, look at that, it already comes with the program code here. So whatever you put into this file, code.py, is what is going to run as soon as you power the Raspberry Pi. So in fact, it was right, because I didn't even paste this. This was just what came with the firmware. And I can run this program, or I can interact with it here on the shell. So I can first import, then do a bit of setup to say where the LEDs are. And this LED is the onboard LED, the one that you saw blinking before. And then I can do like LED value equals true. And before I run this, let me do a quick picture-in-picture here. So as I run this, oh, and I want the picture-in-picture to be on top of everything. So always on top. Bring out to front, is that it? No, I think it's on the view. Float on top, perfect. So as I run this, it flashes the LED on and off. And I think it's super cool that you can write code interactively and experiment with stuff, and you'll see the results on the board. This is great for teaching. I love this. And alternatively, I can also run the whole program, which is just a file in this virtual file system. And as you can even use something else. You don't have to use Thony. You can use Visual Studio Code if you want. And as soon as you save the file, it's going to start running. So here in Thony, we have this button that you can press, and then it's now running this program which blinks the LED. So it's as simple as that to get started. And the next step is to, instead of blink an LED, to send MIDI data to the computer using a different library. So instead of using digital I/O, we're going to use a different library for MIDI USB. It already comes with CircuitPython, so that's easy enough. And then to work with capacitive buttons. And that part is super fun because you don't have to introduce any extra hardware. Every I/O pin can be set for input. And when you set it for input, there is a library, comes with CircuitPython, that allows you to just touch any metallic part that is connected to the pin, and it will act as a button. So in the final project of the IWI, we are gonna have something like maybe screws or aluminum foil, anything that is conductive, plugged into the pin, and when you barely touch the screw or aluminum foil, the library is going to detect that a button has been pressed. So we'll figure out all the fingerings, and then we'll also figure out how to work with the microphone to get the pressure and send that MIDI data to the computer. So that's as far as I went, and I thought it was a great teaching device. It's super easy to get started, and the immediacy of writing stuff in the shell and seeing it on the board was really cool. So yeah, that's my update, and those are the next steps.
Awesome. Did you have a microphone yet?
Oh yeah, I got the microphone module, and incidentally, the microphone module was like €5.50, so it was more expensive than the microcontroller, which I find amusing. And the microphone module is sending, you power it, I actually tried it already, so you power it through the 3.3 volts that is available in one of these pins. And I hooked it up to the oscilloscope. What the microphone module does is it just sends a signal between 0 and 3.3 volts. And I was blowing into the microphone, and it was sensitive enough to detect a difference between like and. So it's gonna work out fine, hopefully. And then you hook up the analog output from the microphone module back into the Raspberry Pi, and one of the pins can be set as an analog input, so that will translate to a number between 0 and 1024 or 0 65,536. I don't know what is the resolution in terms of bit depth, but we are not interested in capturing that signal and recording it. We are only interested in averaging it to detect loudness, so should be fine even if it's a lower resolution. And the microphone module itself is just an electric microphone with a built-in amplifier and voltage regulator. So it's a very simple module, and yet it was like more expensive than the microcontroller. But in any case, yeah, that's what I'm up to.
Cool. Sweet. Should I go next?
Yes.
Yeah, it sounds like you're still adjusting things, Fotis.
I'm almost done. Oh my god.
Or see, we
Oh my god, I just figured out something. Oh my god, I'm so silly. Oh.
We all are.
Oh god, okay. Bo, are you ready or should I go? What do you... I can do... I'm fine with both.
I have a quick one.
Sure. Okay.
Let's share
Water.
While setting that up, let me see.
Oh my god, I was pressing the wrong keyboard shortcut. Oh god. Oh god.
You're gonna be fine. You're gonna be fine.
Oh god, I'm turning red. Yeah.
I've been, I wouldn't say busy, but do you guys remember that when I tried to make a thing that made overtones in the bass register?
I remember that.
I split it up with a 6 dB filter for upper register and lower register, and I did a lot of testing of that, and it didn't sound good, as good as I was expecting. But
guys,
Yes.
I can't hear Bo.
Oh, I thought that he was just thinking in the middle of a sentence. But did he get disconnected? Your audio was cutting off, but we can still see you moving your mouse. So
okay,
so probably just a hiccup.
How much of where did the feed?
Can you rewind 3 sentences?
Yeah.
Well, that splitting up frequencies and distorting the lower register in order to get overtones so you can hear it on smaller speakers. It didn't work quite as well as I was hoping for, but I think I may have found a way to create a different type of distortion. And it's a distortion that is sort of in a reverse dynamic. Can I have some as well?
Yes, please. Here it is.
What is it? Yogurt or
Sorbet.
sorbet? Yeah, you told me ice cream. Sorbet. Oh yeah, sweet. Oh, nice. It's
Quite
too cold
literally.
here. So what I have created is a thing that starts producing overtones it produces more overtones as at a lower level. I'm hoping this it's going to work as planned. And as I increase the level, it's producing. So this is going to be a lot of overtone.
Mm-hmm. And then some fold-over distortion.
I might put in some code that will cut out the fold-over, but there you go. I also added a filter to this. So it cuts out some of the upper registers in order to prevent aliasing. But what it does, should I tell you how it works?
Yes,
Yes,
please
sir.
show us the code. Mm-hmm.
It compares a square of the signal against a square-rooted part of the signal against, and then subtracts the squared part of the signal. So lower levels are going to get higher and then sort of even out the closer to 0 dB we get. Hence, you can see the code, doesn't make sense. It's just a low pass filter. So the first thing I'm doing,
I'm staring at this and trying to make sense of it. You are... Okay, I think I see what you're doing. Yes, okay.
Yeah. So I'm square rooting the signal and then subtracting the squared signal from that, which means that lower levels are going to be higher. And in this case, I added so that I can adjust the squaring and the square root. So I'm making exponents of them. But
why do you hard clip to begin with? On the first line of code, you are hard clipping it.
Yes, that's for the fold over. So what happens if I don't do the hard clipping? It's going to go completely berserk once it reaches 0 dB. The signal just goes bonkers.
Is it perhaps dividing by 0 somewhere?
I'm not sure. I don't think so. I think it just goes back in that sort of square rooting and subtracting the square. I think that's it.
Did you
Plus,
record something for us, like in terms of
of
sample for how this sounds?
I can produce some. Let's do one. So now you're gonna. The thing is, it's one. I have one channel that's unprocessed and one that's processed, and Skype is mono.
Ah, yeah, right.
But should I just cut out the?
Oh yeah, right, good idea, because you will listen just on one side, but since we are listening in mono, for us, it will be fine.
Yeah. So, can you hear it?
No.
No.
Oh. Done this before, haven't we?
Ah, yeah, the
You
good
tried.
old sharing with... Ah.
That was an accident, but there you go.
A happy accident.
Yeah, very happy accident. I keep forgetting how you route the audio. Fotis, this is your area.
First of all, did you check the share computer audio in Skype?
One. I need to First stop sharing, and then
The thing that we would like to see to be able to help you out is the window you see as you're starting a share. How I
can you hear it now?
Oh, yeah, there it is.
Yeah.
Square wave.
So 120. Let's do 240. So this is somewhat of an overtone thingy, but as it distorts more and more, producing more overtones and sharper overtones. So I'm thinking of adding this to, first of all, subtracting the original signal so that it doesn't so the bass frequency doesn't get added to the original sound. But I want to sort of mix this in. First of all, do the high passing and low passing, and use this on the low passing, and then.
Bo, could you please turn down the master volume of Reaper?
Absolutely.
We're having trouble hearing you.
Absolutely.
Okay.
Is that better? We don't
Yes,
need to
much
hear the
better.
audio now, though, do we? So, but the idea is to subtract the original signal, so I'm just getting the overtones and then mixing that in with a mix level thingy. So there's my thing for today.
Nice.
All right.
Yeah. And as is maybe a bit of a side note, this is the sort of the code that I was working with last time, and I might have an idea if this could work as a limiter, again splitting the signal to a high and a low pass, and then running that formula on both of them, and maybe that would make a good limiter. I'm not sure, but that's what I'm gonna work on.
I have a question about how
So-
you're splitting the signal. Are you using filters that are designed for crossover, as in if you didn't do anything to the low and high signals, would they add back to the original?
Yes.
Cool.
Yeah. So the ones that I'm using are let's see, for code snippets. I'm using the regular 6 dB one. So this one. So that's going to split up. So if I'm using the same weight value, I can just at a later stage I can just add them. So then they sum up perfectly. So.
It is. Okay, these are just notes. I was going to point out that it is interesting that you're doing a low pass on the left channel and a high pass on the right channel, but it's just a sketch. I get it. All right, should we move on?
Yep.
Yeah, I suppose the answer is Bo's microphone is misbehaving again, but since he said that was most of what he had, so we are going to move on and get back to you, Bo, if there is more that you want to
Stop
share.
sharing.
Okay, we can hear you again.
Oh, is the audio effed up again?
Yeah,
Why is it doing that?
Yeah, it was cutting out for a moment, but we are back.
Uh-huh.
We can
Okay. Yeah. Yeah, I'm done. I'm all done, so go ahead.
All right then.
Okay.
Fotis is looking at the
yes.
screen and looking worried. Do you want to go last?
No, I'm okay. I'm okay. I'm just tired. I'm not worried. Everything is all right. I fixed everything. I fixed the universe. So first of all, remember how this is what I've been working on this time. Remember I've spoken about this in a previous group, my anti-Juno synthesizer. And right now I've been doing this. I'm replacing the images with actual vectors. So the interface is going to be 100% vector-based and resizable.
Cool. So to do that, you are designing in HISE, or not really designing, but you are like drawing in HISE.
Yes, I'm drawing inside. Yeah. So this image is actually I have turned down the alpha, it's not completely the opacity, so I can draw the actual vectors on it.
How is the experience of HISE as a graphics design tool?
Well, I'm getting the hang of it slowly but I wish it had like buttons for specific functions instead of just relying on keyboard shortcuts that you don't know exist, and you had to go to David Healy's YouTube videos just to figure out that you have to press Control and D to duplicate a label, and you have no option to do it in the GUI itself, so that's a bit of hurdle.
Very Reaper-like to have keyboard shortcuts that no one tells you about.
Exactly. But yeah, this is my HISE update, but I have something else to show. Two things, in fact. The first thing, Bo asked me to show it. I forgot what. Oh yeah, draw some space. What was it called again? Forgot. I've shared this to so many people and I forgot the actual URL. Oh yeah, I found it on GitHub of all places. So on to GitHub, my friends, the place where I originally found this thing that I'm about to show.
But that was a web page. That
yeah, it is a web page, yeah. But I forgot the link. I have probably bookmarked. Oh, Shape Your Music, there it is. That's how it's called. Did I? There it is. I bookmarked it. There we go. So this is Shape Your Music. And what is this? It's a vector drawing app where you can draw music. So let's draw a random shape and press play. It does have some dropouts. Wait, how about now? Can you hear the audio?
I can hear the audio, it's clicking a bit, but it's fine.
Yeah, it's clicking, yeah, because Chrome is a bit overloaded right now. But yeah, you can change the instrument, for example, piano. It's loading the samples. And you can select colors, so you can make different instruments with different shapes. And all of this is logged to a specific... Wait, is the audio coming from... Oh, okay. You can also change the scale, the tempo, and the key of your song. And when you're done, you can save your project. You can export to audio and even MIDI. And you can do some edits. You can add more points, which will, and you can actually see which notes you're doing. I don't know how you can do curves yet. I don't know if it's even possible. But yeah, there are tons of little things that you can do. You have ADSR, and also you have 5 different sound generators, and then you have your basic ADSR stuff. Anyways, and then you can
the positions on the screen and the notes or intensity or what have you.
I think so, yeah. I didn't spend much time with it, to be honest, because there is something else that I have focused on that I want to show you guys that's even crazier than this. So that's about it. Are you ready for the other thing that I have?
Sorry, but it's kind of a sequencer. That's what it is.
Yeah.
It's a sort of a weird graphical sequencer. That's cool.
Yeah, and you can adjust the tempo as well.
Uh-huh.
There are some stuff that oh, there's also a grid, so you can make the nodes snap to specific grids. That's always cool. but already I have flashbacks of the grid-based GUI designer in HISE, and I'm slowly trembling from inside. I don't know if you can see it. And also you can record everything you make to an audio file, so there's that. And that's about it. Now, are you guys ready for the other thing?
What is the other thing?
Bring it on.
So let's go to Reaper. Let's not spoil it yet. Let's go to the study group folder. By the way, I found, before we begin, this is a little prologue, but I found a little thingy called Flex Asia, which is a new open source Asia driver. I'm gonna link it in the chat once we're done, because Asia for all has become increasingly annoying. So I replaced it with Flex Asia, which is incredibly lightweight, just a few lines of code. And even the GUI is separate, so you can not even install it if you have a very low-end machine or like a dummy computer that doesn't have graphics or so. And the interface is separate, and you can choose it. It gives you a lot of freedom in a very clean way.
What is the annoyances in ASIO for all? Because that's what I have used in the past.
Basically, this is it, the third window. This is basically the entire driver. This is what it is, just a few lines of code. And when you do changes, you click Save As, and you overwrite. Sorry. And you can overwrite to the TOML file, which is the settings file. So it's very clean, very convenient, hassle-free, and I love it. Now, onto the thing. So this is a voice file of me in two different flavors. So this is the first one.
Study group. Woohoo!
And this is the second version.
Cool.
But what is it? You may wonder. Is it a vocoder? Is it a VST? Is it something I cooked up in HISE? Nope. But to find the answer, we have to go back in time.
This is just the sound of your natural voice. Now you can speak like that.
Yes, this is my natural voice. Yeah, so let's go back in time. So, are you familiar with this, the Sheep Shaver GUI?
No, what is the Sheep Shaver GUI?
It's like VirtualBox, and it allows you to load Mac OS 9.
Jeez!
What?
Oh my god.
So yeah, it's free, by the way. You can get it from archive.org. It used to be hosted in Columbia University, but the link is down, so you can find the archive link. I'm gonna link this as well.
It's free. I'm gonna download now.
I remember that there was something that you could run in the browser even. You could simulate macOS, old versions of macOS in the browser. Very cool stuff.
Yeah, but this is even better because I can have access to my actual Windows hard drives. Ignore this. You're gonna get those error messages, but I had no problem with this. So, back in the early days of 1992, there was no Reactor, there was no Sync Modular, there was no Pure Data, there was no Max, but the guy who created Pro Tools and DigiDesign, which later became Avid, had created a little other thingy before Pro Tools, and that thingy was called TurboSynth. Now this is one of the earliest modular synths in computer history, in personal computer history. And I don't know if yeah, let's see if the oscillator works this time. You create nodes and you connect them like God intended to. And yes, I have some issues with the real-time audio. I have to, probably it's a sample rate error. I have selected, where is the other thingy? Oh yeah. Yeah, I have to do some tweaking in order to get the built-in audio device work, but the good thing is that the save audio works, and you can export samples and then load them in Windows. Now I'm gonna link the exact tutorial I used for this, and it's super helpful because there are a lot of loopholes you have to go in order to convert a file and load it into this thing. But the gist is you create a sample module, you load the file you want, for in this case the study group woohoo file, and it even tells you that it's a stereo file. And there is a way to process stereo. There are a lot of things that I need to do, but this is the waveform, and then you can connect it to the thingy like we did. It's a little tricky, like cables. Come on. Oh yeah, you have to delete the oscillator and place it here. Or I guess you can do both. As a YouTube user did it, but I can't apparently because I've been a bad boy. No, you have to connect the oscillator to the right output and the sampler to the left. So you can have a sine wave and the file playing at the same time. But here's when it gets interesting. Let's delete this thing. And instead, let's take the sample and choose convert to oscillator. Now you can choose a fundamental frequency, let's say 120, and track frequency changes. And select OK. We're gonna wait for, oh, the conversion is already over because this is 2023. Back in those macOS 9 days, you had to wait several minutes for this conversion to be over. But apparently we did it. So let's connect the outputs again. I'm gonna change it back to mono because it's a bit frustrating. The original file was in mono. And let's save it to AIF, and let's change it to output 120 because this is the amount of kilohertz that I used. I'm gonna save this project. Also, I figured out that in Mac land you had to control click instead of right click. So that's funny or interesting. Yeah. Also, the desktop doesn't automatically refresh, so I had to double click on macOS 9 in order to make my file appear.
Did the mouse have two buttons already in 1992?
No, the Mac systems, they just used one button mouses. So no, just a left function. You had to control, like Fotis said, you had to sort of control click. I don't know exactly which version they changed that, but they stuck to it for quite a while.
So we made our little file, and let's duplicate it. And now I'm going to my PC hard drive. What? This is heresy. How dare you use Windows in Mac? That's not what Steve wanted. By the way, did you know that Brian Eno created those blingy sounds in Windows XP? When you boot up the system and when you shut down those.
That is Brian Eno?
And also, did you know that Brian Eno used a Mac to make those sounds because he hates PCs? So she was hired by Microsoft to create sounds using Mac. That's hilarious. Anyway, we copied it to my trusty SSD, and we shut down Mac. Bye, Mac. And here's a file. I'm gonna rename it to AIF because I forgot. And let's go back to Reaper. The tutorial also tells you how to make Mac understand how the AIF file extension. Now it's not a tempo, you stupid thing. It's a frequency. And there you go. This is how you vocode your stuff.
Yeah.
Cool. And the thing is that I originally wanted to use it for an ambient music project of mine, but now that I figured out the gist, I'm gonna do some adjustments to the samples of the analog waveforms from Sample Science, which I am going to use in my own synth, Go. But maybe, just maybe, I might be able to implement some of these methods into HISE. Who knows? Once I figure out the interface stuff, the other stuff is going to be easy, right?
This is so impractical. I love it.
Yeah, it's like using a forklift to pick up a pencil from the floor.
Yes.
And if you're interested in learning more about this fine piece of synth history, you can get the manual in PDF. And also my dad OCR'd it. So on the count of 3, everybody say, "Thank you, Fotis' dad." 1, 2, 3. Okay, one more time. 1, 2, 3.
Thank you, Fotis' dad.
Thank you, Bob.
Is he in the room or is he watching the stream?
He's in a different room, but he's watching right now. So yeah,
All right.
he'll probably post in the chat.
And he knows English.
Yes. And yeah, the AB fine reader did do some mistakes, but the 99% of the text went well. And also it recognized the font, which is impressive. It's Century Gothic. So I'm gonna read this thing. I'm gonna find just how impractical this thing is. But it's funny to see how these things were working. And who knows?
Tail just said in the chat, "Thank you, Fotis' dad."
Thanks, Tail. I still haven't gotten back to working on that JSFX, by the way, because I was too busy going back in time.
That's a necessary excursion, yes.
Yep.
I'm glad you're doing that.
And yeah, the bad news is that I didn't get to finish Go in time for September, which is Synth month. I only have 3 days before Synth month is officially over. But I did this, so technically I won my Synth month challenge by learning a completely different thing. So there's that.
It's all about the friends we make along the way.
Yep. And by the way, this thing was used by 9 Inch Nails. This is how I found out about that. And after that, there was Sync Modular, which was a similar thingy, and the creator of Sync Modular was hired by Native Instruments, and he evolved Sync Modular into Reactor, while TurboSynth's DNA, I believe, is still inside Pro Tools, somewhere hidden deep inside its source code. And I don't know if you heard the news, but Pro Tools, ever since Avid was bought a few months ago, I think that the new owners of Pro Tools are trying to get into the loop-based market, and they are making like the thing that Ableton has with the session view with the little rectangles where you place loops and you play them in real time. They're gonna do that in Pro Tools. Because hey, Pro Tools still exists. Everybody still has to make AAX plugins. Dear Lord, why won't AAX just die? Why won't Pro Tools just die?
Come on, I think it's nice. I like the idea of having grid-based composition in Pro Tools. I have never used Pro Tools, but the more the merrier.
Please don't. Please don't. This thing is in life support. We should just let it perish in the ocean. There are so many better DAWs out there. Please don't encourage.
That's what the pros use.
Yes, the industry standard. If you want, you can check out an amazing video by Spectre Sound Studios, a YouTuber called Glenn Freaker, who is a YouTuber and a music producer. And he made a troll video saying why Pro Tools is better than Reaper. He is a Reaper user. He is just powering Pro Tools. And I'm going to link that as well. He makes some great points about how Reaper gives you everything that Pro Tools gives you at a very big fraction of the price. But it's not what the pros use, right? Reaper, that's just for nerds.
What do you mean?
Anyway, that's my update for today. And I'm going to stop sharing my screen and I'm going to send some juicy links in the chat.
All right.
Hope you enjoyed my Fotis delves into synth history lesson.
Yeah, let's hear from Siwitz, and then we can play one or two stages of the game, right?
Yep.
Sorry guys, there is nothing to hear from me for today and past all the time.
Okay, for real, because we hear that a lot, and then you show us something shiny and new and amazing.
Oh, sorry.
Okay, so let's play the game.
Yeah, so I'm gonna load Steam. Just wait up, I'm gonna take a little break for a couple of minutes and I'll be right back. Sorry to keep you waiting. I'm gonna get something.
Sure.
I'll be right back.
While you're doing that, you all sound like there is a vocoder flanger effect. Okay, I think I know what that might be. That's unfortunate. Okay, I will take care of that in a second. But Tail is saying that macOS 9 is cool, and I played with it a little bit in the browser, and I agree, it is some cool stuff. I wonder about the longevity of code. I wonder how much of this piece of software that Fotis was showing us is still alive in Pro Tools. Because I know that there are like mainframes that are running code from decades ago. And in theory, a filter is a filter is a filter, and C++ is C++. So I wonder if there is still, like, in these big pieces of software, if there is still like code from the 90s lingering around. I wonder what that means for maintainability, because it's working so you don't have to touch it, or there are better way of doing things and you have to do some maintenance on that part of the code. Something that I wonder about. Someone donated a fully working Macintosh Plus to my company a while back, which I think has OS 7. Jeez, that's old. We have no use for it really, but it's kind of cool to see in real life. And yeah, this vocoder effect is because I am not wearing headphones. That's what that is. So I'm gonna wear headphones, but then now I'm gonna do something else. I'm gonna mute the microphone. You see, it will be fine. I will fix the echo. Thanks for letting me know. And yeah, and thank you, Fotis, is that.
So OS 7, that was still monochrome. That was just black and white screen, like fully white through the black, wasn't it? There was no. Was it 4-bit color, black and white, 8-bit?
Let's see.
I don't remember. So the graphics was really crude.
Yeah, I am not sure.
I used to have a Macintosh Plus as well.
So yeah, that's what I see. That's what I imagine when I think of an old Mac.
Yeah.
And I was in a museum and I saw this. It was super cool. I was in the Museum of Video Games in Berlin, and they had all the consoles from my childhood and even older things. Like I was not using Macintosh this kind of anyway, and they had some of this there, and some of them you could even play. So I played like on a Commodore 64. I highly recommend, if you are in Berlin, definitely go to the Museum of Video Games.
Cool.
And
So the Plus didn't have floating point processing. I think it was at the SC30 that got that.
yeah, let's see. So
I'm back.
the CPU is the clock of the CPU is measured in megahertz. Cool stuff. All right, so here's what I need to do to
1
avoid
meg of RAM,
echo.
that's good.
No, if I do this, then yikes. If I do this, then I won't be able to speak. But speaking is important. I like speaking. I'm gonna
I
use
say.
headphones.
You speak a lot.
Busted.
Yep.
That's why I like you.
Oh,
Yeah, so to prevent the echo, I'll need to wear headphones. Bummer. Anyway, that should do it. Yeah,
Right. Are you excluding me from the?
I am excluding you from the study group because
Oh my
of the
God,
echo.
You are
Unforgivable.
Watch it on the phone.
friend. What?
Yeah, great suggestion. On your computer, go to YouTube and wear headphones, and then you will be increasing the view count and the watch hours. Yay! Then go to Patreon and support me on Patreon. Go to Patreon
support
right
on
now.
Patreon, yeah.
Now.
Everyone who's seen this, yeah, she's going to Patreon right now and supporting me on Patreon. You should do the same.
Just give me the
click the like and hit the bell as well.
The link. Send me the link.
Google my name.
Your name?
Yeah. You know how to spell my last name, right?
I can't answer. It's on your website. On YouTube.
All right, Fotis, do you have the,
Yes.
the game for us to play?
Yes, the game is ready.
All right.
Sure.
Let's go to the part of the stream when we play the modular synth game.
What did we, I forgot what was the one we did last time. Oh wait, no, that's the story mode. Whoopsie. Last time we did the logical XOR gate, but it was, the last one was incredibly easy. But the XOR, I can hear my own echo. It's from her laptop.
It is. Isn't technology great?
I think we did this already, right?
This is not
Super
strange
sick.
to me, no.
Yeah, I'm gonna turn it off
Can I go back to our previous stream and see what was the last level we played?
I think it was the XOR, but you don't remember the title of the...
Yeah, I don't remember the title, because
The
they're...
stage?
Anyway, I'm gonna go to the live stream right now. So for people who don't know how to spell the name...
No,
just
really,
bookmark it.
Fotis, I have a different idea. Instead of going back, because that's going to take a little while, why don't we just pick a stage from later in the game
Okay.
and try to work through? I think that
Yes.
can be entertaining, because it will be challenging.
Yeah, it's a harder challenge. Yes, I mean... Oopsie, I've got a minor hang-up. Let's free up some RAM. Boom.
Is this a particularly heavy game?
No, it's not, but
Imagine.
my computer can't handle
Yeah,
Skype. Speed.
that's something that happens to me all the time. I do some things and they work fine, and then I try to stream while doing these things, and my computer is like, no.
Okay, let's do one of those I haven't never solved. The tractor, the tractor gear system. Oh, you get to see the story mode for the first time. So Gordon is one of your friends. He was trying. Let's pick 1 or 2.
Na porta? Ixi. Você quer ela ver quem?
Eu, hein? Nossa, tem cara de gente doida.
Someone is
So,
banging
yeah.
on the door very strongly, and I sent
What was
her
it
to
like?
see. Yeah, I sent her to see who is that.
Oh, okay. Like so many corporate jobs, not great. You feel caged in after a while. Why wasn't the switching system as good as you wanted? According to Eldon Ellis, it was good enough. I think Eldon Ellis was the owner of the barn that you're working. That's deceptive. There is a lot of intrigue in the dialogues. There is a conspiracy. There is a bad guy. It has an actual plot, this game, believe it or not. And I still don't know how it ends. Maybe we'll figure it out together. So, tractor gear system. Output 1 is an alternating signal of constant frequency. We can see it in the graph below. Output 2 alternates between 2 clock signals with different frequencies, 2 and 3 time steps. So you have 2 and 3. Which clock signal to send out to out 2 is decided by out 1. So we have sample and hold, clock, VCA, the end or nots, sum and split. Beautiful.
Beautiful.
Oh, and we have 2 outputs, yeah.
So I would venture that output 1, let's use the clock module, which is new. We haven't seen it before, but it's an alternating signal, so kind of stands to reason that it would be a clock. Can we just see what the clock does? Maybe hook the output of the clock to output 1 so we can see what it is? Okay. So it is a clock going up and down, but we probably need to change what is called the interval for it to match output 1.
Yep. If we change it to 3, the tone is changing. It does pick up some correct frequencies.
Yeah, it is just making the clock more spaced. So bump it up even further.
Yeah, but the thing is that we're gonna need to use output 1 in order to dictate whether or not the output 2 is going to have 2 or 3 times.
Right. We are just experimenting. So let's try to find the right clock. And can you bump it up even further?
Yeah, 5 is the maximum.
5 is the maximum. Okay, so perhaps the best option for us is to have a clock of 4, because then every time that the clock goes up when it was 4, can you play that again so that we have it on the screen? Yeah, so every time that the clock goes up, we want output 1 to switch. Now, at least the time is in sync. Then the next logical step for us is how can we do this alternating signal out of the clock? Oh, and it's actually the description. It's an alternating signal of constant frequency. We found the frequency and we have a clock of that frequency. Great. How can we come up with an alternating signal? What are our modules again?
The sample and hold,
Sample
the
and
clock.
hold. Sample and hold could be a good one.
Yeah.
So we could have, I suppose, I'm not sure I know how sample and hold works in this module, but it stands to reason that it's listening to the input. Then you send a gate signal, and it's going to sample the input and hold that on the output.
For an interval, yeah.
So I guess what we want from this clock that we already have is for it to be the gauge, because we want the sample and hold to change the value every time that this clock that we have sends a pulse. So hook the output of the clock to the gate of the sample and hold. Does it make sense?
Yes.
Good. Now we want the input of the sample and hold to be something that is going to be down and up. I don't know what to hook to the input. Do you have any ideas?
Output 1, perhaps. No, you can't. No, that's
going to be
That
low
can't.
all the time. Yeah.
it's counterintuitive. Boom.
Well, I do have one idea. Do we have a module to do notch?
Yes, we do.
Awesome. So what we can do is hook the output of sample and hold, probably to a splitter because it's going to go to multiple places. But the output of sample and hold could go to the input of the notch, and the output of the notch could come back as the input of the sample and hold.
I like the way you're... So this is a feedback loop.
Exactly.
Huh.
Yes. Now, can you hook the output of the splitter to output 1, and can we listen to that? Yes, that. Hook that to the output.
Oopsie. Potential infinite loop detected. Playback will not continue. We broke it. Oh my god! We just got a Steve achievement. Created Turing complete. We did the wrong thing and got an achievement. Yay. So yeah, thanks. Thanks for ruining my modular forever. Boom.
Did I burn your computer?
Yeah. You burned the universe. Now the world is not gonna live. We're not gonna save the dystopian post-apocalyptic universe with this modular thing. Anyway, so this didn't work. We have the endor and also the VCA. And remember that the VCA can function. No, I forgot. I was thinking of the attenuator module. But yeah, the VCA cannot function without an input, can it? Or can it? Can you just use the CV and outputs?
I suppose if you do that, then you will be amplifying, because that's what it is, right? A VCA is a multiplication sign. You'll be multiplying the CV by the input, which is perhaps 0 if there is a pull-down resistor, or it's just noise. So I'm not so sure about that.
We can look at the hints if you want.
Yeah, why not? Let's look at a hint.
Okay. You have no source signals here. You have to generate the outputs from scratch yourself. These are clock signals. Use clock modules to generate them. You need to store the clock pulse in memory for out 1.
Yeah, that's what we are trying to do with the sample and hold.
Use sample and hold modules. Okay. This is the final hint. It's not going to give you any more.
You can use logic modules to toggle between clock signals of different intervals. Okay, that was an idea that I didn't want to explore first because it sounds a bit iffy, but yeah, let's have another clock module.
A 2 and a 3 one, like this.
Yeah, maybe.
I'm gonna disconnect everything and start over.
No. Keep everything in there because it still kind of makes sense. But now for the input of the sample and hold, we want the other clock. The one that you just added. And then, hook the output of the sample and hold to output 1. And I guess in theory, you can even remove the splitter and the notch modules.
Oh, we're getting there. What if I switch the values? No. It was worth a shot. So we can use a logic module to pick the correct outputs for sample and hold, I guess.
Do we have a sum module?
Yes, we do.
Nah, I don't know what I would do with that right now. I was thinking that perhaps we could try and return to our previous idea of using the not to invert, but then something for the initial condition. But I'm not sure how that could be laid out. I still like the idea of using the clock. Hang on. The clock that is going to the gate was supposed to have an interval of 4, not 3.
Oh.
Yeah, let's play around with this concept again.
Huh.
Now it's up all the time. Change the frequency of the input clock. Or the interval, I should say.
Oh.
That's something.
We're halfway there.
Yeah, try different numbers there.
Like this.
Yeah.
4 and 4. 4 and 3.
No. The 4 on the second one I think is right. Go to 5 and 4.
Oh.
Meh. Not quite there.
It's kind of groovy.
That it is. No.
Sounds like one of those Depeche Mode songs that track 4 on from an album.
Oh, it reminds me of Kraftwerk.
Do you want to play around with the second clock? Because I may be wrong. Maybe the second clock should be different. So play around with different values.
Oh, the second one. So I'll keep this one to 5.
Go bananas. Who knows?
Trial and error. This is technically brute force. Don't try this at home, kids.
It seems rather silly to try all these combinations, actually.
Yeah.
Desperate times call for desperate measures. And some of these are almost right.
By the way, I recommend... I remember a little nice indie movie called The Robot and Frank. You guys have seen it?
No.
It's a sci-fi movie with a retired con man played by Frank Langella, and he has an android whose voice is by Michael Fassbender, I think. And the pair decides to work together to pull off a diamond heist. And the robot is particularly useful for using brute force to find combinations in safes.
You know,
what's the title again? Frank?
Robot and Frank. It's a quite nice movie.
One hobby that I recently picked up is lockpicking, and it is surprisingly easy to get started. With those combination locks that people will use at the gym, those things are like, you learn from scratch how to lockpick them in 1 hour.
Yeah, there was this YouTuber guy who would showcase all of the world's safest locks, and he lockpicks them in minutes.
Are you talking about the lockpicking lawyer?
Yeah.
Cool channel. I've been there.
Yeah. Really, I would have never known. Anyway, so this is the one that gets closest to what we want. I guess a logic module would make sense. Or maybe... actually, we could use an OR and we could use 2 clocks, one with the 2 intervals and one with 3, like it says here. And output 1 is the one that decides the OR, like with a CV. So if we do this, nope.
Well, the problem is that we need the solution for output 1 before we can work on output 2, because which clock signal to send to output 2 is decided by output 1.
Yeah, but output 1 is already... Oh yeah, we have to generate the inputs from scratch. Yeah, forgot.
It is so annoying because we have a clock module and it does not give us the level of granularity of control that we would like.
So we have to get creative. Also, we can use an oscilloscope. Will that help?
Well, we are kind of using the output as an oscilloscope. I guess it is handy, but it's not going to be groundbreaking. Huh. I want to return to that first idea of trying to generate the input for sample and hold from just alternating it. It seemed like a good idea. Maybe we did something wrong in the wiring.
Oh. So where should this go? To the second clock?
To to the result of a notch with the output.
Oh, okay.
But yeah, the problem is just that we are not a potential infinite loop detected.
Turing complete.
Well, this is hardware. Come on. Let me see what is the output.
We can measure it if you want.
The problem is that when you send the gauge, then there will be a loop between the sample and hold output and the notch module. So well, let's just use a buffer then, an op-amp.
If you want, we can play a different nerdy game instead. It's called Shenzhen IO, and I haven't even played it. Want to try that instead? And it's
no, I think that now we reached a wall. So that's exactly what I wanted from this exercise. After all awesome. The tutorials and whatnot, we know how.
Here's a real challenge.
Yeah, the sample and hold and the clock. We know how they work. We just don't know how to put the pieces together in a way that would make this happen. So, is there anything that we can do with the VCA? Why would they put the VCA there if it wasn't necessary? The whole signal is digital.
Yeah, sometimes when a module is optional, you hover your mouse and it says optional module only for experts. But in this case, it's not optional, so it will come in handy, I guess.
Yeah.
But then again, there are many solutions to any level of the signal state. And in fact, there is a Discord channel on the official Discord server where people are posting screenshots of their solutions. And it's interesting to see how many different solutions are to the same problem. But we're not going to look at Discord. We're going to solve this thing.
We are going to solve this thing. Perhaps next meeting we will come up with fresh ideas. So I said that we wrap it up. We keep thinking about this. We resume on the next meeting and try to figure this out. The tractor gear system is the name of this stage.
Anybody who looks at Discord is gonna get shadow banned forever.
All right.
So we did get a Steam achievement, so there's that. And according to Steam, 33.1% of players have this achievement. So yay.
It's exactly a third. That is surprising. All right. So with that, let's wrap up. I will check.
Oopsie. What's happening?
Aline is here in the chat. Hey. So, let's wrap this up. Thank you. First of all, JUCE is gone and Fotis is gone. I wonder if my connection is...
What happened?
I don't know. But they are gone. But anyway, I want to thank them for joining us. I want to thank you both for joining us.
Thank you.
Well, thank you, Leandro.
And thank you to Aline for showing up.
Hey, for joining.
And learning about C++,
have you.
digital signal processing, and JUCE.
I'm expert now. Already.
She's an expert now. Amazing. And thank you to Tail and Strato and everyone else who's watching this. It's amazing to have you here. And I'm looking forward to seeing you again in the next meeting, 2 weeks from now. Hopefully, maybe. You never know. Life is
Gang
complicated.
signs. Yay!
All right. So, yeah, that's it. Let's wrap up. Thanks for being here, and I'll see you next time.
Take care, everyone.
Thank you for watching the stream. You know how great it has been. Or maybe it sucked, and I am glad that you stuck with me. And soon we'll all be back together for some more coding or talking or chilling. The next time I'll be streaming.